go to page 83 in your journal and get the definition for Pascal's triangle. Then we're going to take a look at the core concepts below. You can see on the left-hand side, these are all of the general forms. So if I have a plus b times a minus b, then when I FOIL or use the distributive property, it just ends up being a squared minus b squared. So think of these as shortcuts, and when you have a plus b all squared, you can do shortcuts and use this formula to solve, like in your example on the right. So the right-hand side are examples, and make sure you take a look and read through that. Then go to example 6 in your notes, and we're going to see that for part A, this looks like the difference of squares, so that's the first part of the core concepts. So I can take a squared minus b squared, which means I'll have 4n, that's my a, squared, minus 5, that's my b squared, because this is kind of like a plus b times a minus b. So now, if I simplify that, I'll get 16n squared minus 25, and that will be my final answer. For part B, this is the difference, and it's kind of like a minus b all squared. So if we use that from the journal, look at this concept right here, a minus b all squared, and we're going to use that idea to solve part B. So I'll do a squared, so that's 9y squared, minus 2 times a times b, and then plus b squared. So when I do this, I get 81y squared minus 36y plus 4. And that's my final answer. For part C, we can think of this like the third part in the journal. So this looks a lot like the cube of a binomial. So we're going to follow a to the third plus 3a squared b plus 3ab squared plus b to the third. And you can look at this example for help. So I'm going to focus on, I have a, b, that's my first part, to the third, plus 3ab squared times 4, plus 3ab times 4 squared, plus 4 to the third power. So if I rewrite this, I'm going to make it look nicer. And this is what you should get here. A to the third, b to the third, plus 12a squared b squared, plus 48ab, plus 64. And this is just a shortcut. You could have distributed this and multiplied ab plus 4. You could have done it the long way 3 times. But instead, we're using this shortcut now so that we don't have to do as much work. Now take a look at example 7. This has to do with Pascal's triangle to expand binomials. So let's look at part A. So looking at Pascal's triangle, I know that I'm going to start this off with my coefficients, 1x to the 5th plus 5x to the 4th times negative 2 plus 10x to the 3rd times negative 2 squared plus 10x squared times negative 2 to the 3rd plus 5x times negative 2 to the 4th, and then plus 1 times negative 2 to the 5th. When I simplify this all, it becomes what? So let's multiply the numbers and get rid and clean that up a little bit. So this should be your final answer for part A, and then I'm going to restart and do part B. Copy this down. So for part B, I'm going to use the binomial to the third power rule. So I'm going to say 1 times 3y to the third plus 3 times 3y squared times 1 plus 3 times 3y times 1 squared plus 1 times 1 to the third. And remember, the first numbers, so the 1, the 3, the 3, the 1, they're coming from Pascal's triangle. And then my next part is coming from, this is my A, this is my B. So we have A, B, and B. So the powers for A go down. They start with my highest, 3, A to the third, A squared, A to the first, no A. And then my powers go up for B. There's no B. Then there's B to the first, B squared, B to the third. So if I simplify this, I get 27y to the third plus 27y squared plus 9y plus 1.